We are here. Here we are. Little daily 19, our last day of factoring. We're going to look at factoring special cases today. Now, the first set of four examples here, there isn't a ton special to it. You'll just see what happens when I look to factor these quadratic trinomials into two binomials. You get kind of a neat factorization result. So as you can see here with these four examples, they are all 1x squared values. A is 1. So I am going to be able to use the sum and product rule. I'm going to find two numbers that sum, add to 14, and multiply, make a product of 49. So you're going to say, oh, I think that's 7 and 7. Yeah, 7 times 7, 49. 7 plus 7, 14. So your factorization is going to be a mirror image, an identical binomial, x plus 7 times x plus 7. That is totally fine to leave the answer as x plus 7 times x plus 7. Some people just say, oh, well, it's x plus 7 times itself. So, yeah, of course, if you want to multiply something by itself, you can definitely square it. So another way you could write this is x plus 7 squared. You don't have to, but we are just showing you here this type of special case. When you multiply a binomial by itself, you could write it as that binomial squared. So the following three, you're going to look for the double identical binomial that multiplied by itself will equal the quadratic trinomial. So I'm going to set up my two parentheses, x and x, two numbers that multiply to make positive 4, and then add to make negative 4 will be negative 2 and negative 2. Negative 2 times negative 2, positive 4. Negative 2 added to itself is negative 4. And again, if you so choose, feel free to write that as x minus 2 squared. Totally your call. All right. The third of four examples in this spot. Two numbers that multiply to make 225 and then add to make 30 would be 15 and 15. So 15 times 15 is 225. 15 added to 15 is 30. So I think you're kind of getting the hang of it here. Of course, sure, you could write it as x plus 15 squared, that quantity. All right, last one in this category. I need two numbers that multiply to make 25 and then add to make negative 10. Negative 5 times negative 5 is positive 25, and then negative 5 plus negative 5 is negative 10. All right, sure, fine. Go ahead and write that as x minus 5 squared. Quiz test, either one of those is correct. All right, our second of three kind of groups. Second group, this one is kind of a, whoa, if it says to factor and you have only two terms, this one should stick out as a, whoa, this is a difference of two squares. So maybe you want to put a little star next to this one. Here's where you got to think a little bit. With x squared minus 9, you might be thinking, whoa, where's my b value? Where's the number in front of the x to the first? There is none. So another way you could think of this is x squared plus 0x minus 9. So what you're looking to do, x, is find two numbers that multiply to make negative 9 and then add to make 0. Well, 3 and negative 3 multiply to make negative 9, and then 3 and negative 3 add to 0. Plus 3 minus 3. Remember, you can always check factoring using our favorite four-letter F word, FOIL. So if you're like, whoa, is this going to work? Go ahead and try foiling it. So x times x, x squared, x times negative 3x, 3 times x, 3x, and then 3 times negative 3, negative 9. So the negative 3 plus 3 make 0x. They cancel out, so I have x squared minus 9. So that's what I'm looking for. Final answer would be x plus 3 times x minus 3. If you see one of these and it's like, oh yeah, these are perfect squares, you can take the square root of the first term, square root of x squared is x, square root of 9 is 3, 1 plus 1 minus. So if you think of that with example 2, m squared, mm, 81 is a perfect square, 1 plus, 1 minus, square root of 81 is 9. Groovy. 3, here order does matter. So I have to take square root of 64, 8. Square root of a squared is a, 1 plus, 1 minus. So it does have to be 8 plus a and 8 minus a. The 8 has to come first, the a's have to come second. All right, we'll throw one in here with a greater than 1. It's a 4. So since 4 is a perfect square, this will also work out. Square root of 4 is 2. Square root of y squared is y. And then 121 is 11. 1 plus, 1 minus. So 2y plus 11, 2y minus 11 would be your factorization. And then finally, there won't be a ton of these, but wanted to show that to you here so you could take a look with taking out a greatest common factor. There might be a few of these, but don't spend too much time with it. So if you get like a crazy trinomial here where you're like, oh, how am I going to guess and check on this one? Sometimes you can look at the numerical values. So in front of our x squared, a is 3, b is 30, and c is 75. You notice there that they are all divisible by 3. So you can divide everything by 3, factor out a 3. You'll be left with 1x squared. 30 divided by 3 is 10x. 75 divided by 3 is 25. So keep your 3 out here just as your friend and mine, a floater. And then you can factor out the remaining trinomial. It's a 1x squared, 2 numbers that multiply to make 25, add to make 10. 3 times x plus 5 times x plus 5, good. And of course, if you want to write it as 3 times x plus 5 squared, that is legal as well. Finally, with example 2, notice my greatest common factor is a 4. So if I take a 4 out of the 4x squared, I'll be left with 1x squared plus 6x, and then 44 divided by 4 is 11. So can I find 2 numbers that multiply to make 11 and then add to make 6? Well, 11 is a prime number, so it has to be 11 times 1. So is 11 times 1, 11 plus 1 equal to 6? I don't think so. If you read the instructions, it said, if possible. So here, I cannot factor it any further than taking out the greatest common factor. That's as far as I can go. Another time you might be able to factor out, take out a greatest common factor is with the difference of 2 squares examples. Notice here I have 2 terms. They're not perfect squares. Oh, but 2 and 18 have a greatest common factor of 2. So if I divide both these by 2, take out my floating 2, I'll be left with x squared minus 18 divided by 2 is 9. And I saw from my prior set of examples, x squared minus 9 can be broken down into x plus 3 times x minus 3. So there you have it. One more of the difference of 2 squares here for your health. We need nobody getting sick. If I take out a greatest common factor of 3 and 48, that would be 3. I'll be left with a 1x squared. 48 divided by 3 is a sweet 16. And then finally, x squared minus 16, xx, 4, 4, one plus, the other minus. There we go. The grand finale. 3x squared plus 6x plus 3. Yes, 3, 6, 3 has a greatest common factor of 3. What's left is a 1x squared plus 6 divided by 3 is 2x. 3 divided by 3 is 1. All right. X. Can I find two numbers that multiply to make 1 and add to make 2? I think 1 times 1 is 1, and 1 plus 1 is 2. So if you'd like, go ahead, feel free to write it as 3 times x plus 1 squared. There you have it, friends. D19 in the Libros, the books. Have a great one.